So these two stickers, same shape, different sizes. Okay? All right. The second one says, suppose the sticker and the decal shown in the next are next to each other on the computer screen. If you zoom in 125%, would they stay the same or would they be different? So if I zoom, do they change shape? No, they just change size. Zooming only changes the size but not the shape. So here are our vocab words. We're going to be talking about dilations today, which is like transformations. Remember when we did the slides, the turns, and so it's rotate, translate, rotate, and reflect. So we did slide, turn, and flip. This is one more of them. It's called a dilation. So I will let you write and then we will talk. Hello. Okay, so just let them in. That's fine. We'll make it work. Just there's fine. Yeah, I'll see what numbers are and then we'll plan accordingly. It's fine. Yep, we'll make it work. Yep, bye. Do you want a vocab sheet? Yeah, I'll make you one. And then I will share my OneNote with you. So then what? I forget. One of the paras would print off the OneNote and have it all printed off and then use it as a note-taking guide. Okay. So I will share that with you here right now. Oh, I'm sorry. I didn't mean to do that. I want to freeze the screen and then go here. Okay. Yeah. Okay, a dilation. If you've ever been to the eye doctor, sometimes they dilate your pupils. when they dilate your pupils, what happens to your pupils? They get bigger. They open up. So then the eye doctor can see to the back of your eyeball. Okay? Sounds kind of gross. If it's really gross to you, you don't want to be an eye doctor when you grow up. Okay? I can't even put in contacts. I can't touch my eyes. It just, bugs me too much. So definitely not an eye doctor for me. So when you dilate something, you make it bigger or smaller. Where you dilate it from is the center of dilation, and how much bigger or smaller you make it, right up with Caleb. How much bigger or smaller you make it is your scale factor. That's how much bigger or smaller you make it. So an enlargement is bigger, the new figure is bigger, a reduction is smaller, the new figure is smaller. So if we look, this triangle ABC is the original figure. Okay? It's the pre-image from last semester. It's what we start with. The red one is the image. Okay? So it got dilated. Okay? So P is our center of dilation. That's where we're dilating from. And everything, if this is like 10 away to get to B, then here, if it's dilated by 1/2, this would be 5 away from P. And if A is like 8 away, this would be like 4 away, and this would be like 8 away, and so on. Okay? And if C was like 12, then this would be 6. Okay? Everything's half as far away from P. Okay? That's what a dilation does. Now, if the center of dilation is inside of the object, here's a quadrilateral, kind of a kite-looking type thing. Okay? And they made it twice as far away. If this was like 2, then this would also be 2 to make this 4 away, twice as far. If this was 3, then how far away would x prime be? 6. If this was 4 away, y prime would be 8, and so on. Okay? So, dilations. Here's the ones that I think are easier to look at, easier to see than the ones that are outdrawn in space. When you have a graph, they're a little easier to see. Now, your original figure is A, B, C, D. Your new figure is A prime, B prime, C prime, D prime. How far was A away from P originally? How far, Albert? How far is A away from P right here? 2. It's 2 away. How far is A prime away from P, Jenny? It's 6 away. So, if the new is 6 and the original is 2, what do you think the scale factor will be? What will the scale factor equal? Well, what is 6 over 2, Kennedy? 3. And our scale factor is 3. Everything on this object is 3 times bigger than everything on this object. So if this is 2 across, this is 6 across. If this is 3 high, this is 9 high, and so on. That's how dilations work. It makes everything that much bigger. How much bigger? The scale factor bigger. So everything in this case is 3 times bigger. Okay? So on this thing, what's the scale factor? The black is the original. The red is the new because it has the primes on them. Okay? It has the primes on them. So the new is what goes on top of the scale factor. The original is what goes on the bottom of the scale factor. So it's always going to be new over original. So what's 18 over 12 reduced down to? What number goes into both of those, Sammy Troxel? 18 and 12. 3 does. To make 6 and 4, something else goes into each of those. What number goes into each of those, Shayna? 2 to get us down to 3 and 2. Okay? So the scale factor equals 3 over 2. Scale factor equals 3 over 2. All right. All right. Next, here's ABC. You have a scale factor of 3. The new shape, if it has a scale factor of 3, do you think it'll be bigger or smaller? Bigger. Okay, because it's 3, you're multiplying each thing by 3. A was originally at 2, negative 1. A prime, you're going to multiply each of those by 3. What's 2 times 3? 6. Negative 1 times 3? Negative 3. B was originally at negative 1, 2. So B prime is going to be at negative 3, 6. C was originally at 3, 0. Where's C prime going to be, Levi? What's 3 times 3? 3 times 3? 9. There you go. I knew you knew that. And 0 times 3 is? 0. So it's going to be at 9, 0. So, if we want to go 6, negative 3, 1, 2, 3, 4, 5, 6, negative 3, 1, 2, 3. A prime is somewhere down there. B prime is negative 3, 6, which is right up here. And C prime is at 9, 0. So if this is 6, 7, 8, 9, somewhere way out here. That's going to be our dilation. It is 3 times bigger than the original. Okay? So that's called an enlargement. When you see it written like this, it says D6. What do you think our scale factor is going to be there if it's D6? 6. Our scale factor is going to be 6. So you take each of the vertices and you multiply them by 6. So W is originally at 2, negative 2. If you take it times 6, what are the new ordered pairs, Kennedy? 12, negative 12. All right, X is originally at negative 4, 2. What's X prime? Where is X prime going to be, Brooklyn? Negative 24, 12. Y is at 0, 4. Where's Y prime? Where's Y prime going to end up, Angel? 0, 24. And Z is at 4, 2. Where's Z prime going to be, Caleb? Can you repeat what you said? Z is at 4, 2. And we're going to multiply them each by 6. Where's it going to end up? 4 times 6 is? We just did it right here. We took 4 times 6. 24. And 2 times 6 is? 12. 12. So 24 and 12. Okay? So that one they didn't ask you to graph. They just said, what are the vertices? These are the vertices. Okay. Now in this one, what do you think our scale factor is going to be, Lucy? 1/2. So is it going to be an enlargement or a reduction? Reduction, because it's a number less than 1. If you have a number less than 1, it's going to be a reduction. Now, they add an extra letter in here. When they add an extra letter in here, they're saying that's where the center of rotation is. So my center of rotation is going to, or not center of rotation, center of dilation, it's going to dilate from point R. Everything's going to be half as far from point R. It's not going to be from 0, 0. So you just can't take the ordered pairs and multiply them by 1/2. Everything's half as far away from R. So what we do is we start from R. Okay? R is at -2, 7. So R prime will be at -2, 7. It doesn't change because that's where we're dilating from. So it stays the same. S is going to be half as far away from R. So right now, S is 6 to the right. What's half of 6, Christina? 3. So S is only going to be 3 away from R. So S was originally 4, 7. So now it's going to be half as far away from R, so it's going to be at 1, 7. Okay, it's going to be at 1, 7. T was originally at 1, 2, 3, 4, -1. Okay, it's going to be half as far away from R. Now, how far down is, or how far to the right is T over? Well, it's the same distance as S is over, right? S was 6 over, and T is 6 over. So the length it's over is just going to be half of 6, which is 3, which puts it at 1. So T prime will be at 1. And then how far down is T? Well, if we go down 1, 2, 3, 4, 5, 6, 7, 8. T is 8 down from R. What's half of 8? Trevor? 4. So we're going to go down 4. 1, 2, 3, 4. So 4 down is 3 up. Okay? 3 up from the axis. So T will be over and down. It's going to be right here. That's where T prime will be. S prime will be here. And Q prime will be right here. Q was at -2, -1. Now it will be -2, 3. Okay? So that's going from R. R didn't move, and everything just shrunk by 1/2. So instead of this side being 6, it's 3. Instead of this side being 8, it's 4. And you just make a rectangle. Okay? That's a dilation. Same shape, not the same size. Okay, a blueprint for a new library uses a scale factor of 1 to 50. Okay? Because they can't make blueprints the size of the object, or else it'd cover the whole floor, and it doesn't make any sense. You have to be able to basically read a blueprint or read a map of what's going to happen. Mrs. Ayer is measuring the reading space on the blueprint for the actual dimensions so she can order her furniture. What are the dimensions of the reading space? So the reading space is, I think, this whole room area here. This is all reading space here. Okay? So, now if it's a 1 to 50 ratio, this is 12 long, or 12 high, and 14 long. Okay? If the blueprint is 1/50th of the actual size, what's the actual size? Will we multiply these numbers by 1/50th to find the actual size, or will we multiply them by 50? Which one would we multiply by to find the actual size? 50. That would only make sense, because the actual size wouldn't be that small. So if we take each of these by 50, calculadora, por favor. Did you get a calculator for Christmas? No, still don't have a calculator? You know where my calculators are located. You had me last semester. What's 14 times 50, everyone? 700 centimeters. What's 12 times 50? 600 centimeters. Okay, those of you, everybody in here has had Mr. Swenson already sometime in your career. Well, some of you had Mr. Hodgin for physical science. But in physical science, you do metric conversions. How many meters? How many meters is 700 centimeters? 7 meters. And how many meters is 600 centimeters? 6 meters. A meter is about the same as what in English terms? A yard. A yard and a meter are about the same. Okay? So this is like 7 yards by 6 yards, or there's 3 feet in the yard, 21 feet by 18 feet. Decent size. Okay. Yama uses a 1/4-inch grid paper to make a plan for his apartment using a scale factor of 1 to 96. What are the dimensions of his apartment? All right. So let's say these are 1/4-inch grids. So an inch is 4 of them. So let's count across. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. If there are 14 squares and each are 1/4 of an inch, how many inches is this across? What's 14 times 1/4, calculators? Some of you don't need a calculator, but for most of you, you do. 14 times 1/4. What'd you get, Lincoln? 3.5. So it's 3.5 inches this way. We count up. If we count up, we go 1, 2, 3, 4, 5, 6, 7, 8. What's 8 times 1/4? Jillian, what's 8 times 1/4? 2 inches. So it's 3.5 inches by 2 inches. Well, let's figure out how big his apartment actually is. It's a scale factor of 1 over 96. So you take each of these times 96. On your calculator, take 3.5 times 96. How many inches is it long, Carter Downs? 336 inches. And 2 times 96 is what? Charlotte, what's 2 times 96? 192 inches. Now, we don't talk about things, especially room dimensions, in terms of inches. We talk about them in terms of feet. Okay? So if we talk about them in terms of feet, how many inches are there in a foot? 12. Divide both of these by 12. What's 336 divided by 12, Savannah? 28. And 192 divided by 12, Candy? 16. Whoop. So it's a 28 feet by 16 feet apartment. Okay? Small apartment. But, hey, it's livable. All right, so dilations. The center of dilation is where you dilate from. The scale factor is what you take each of the dimensions times. Okay? And so scale factor, if there's nothing there, then the scale factor is what K is. If there's two things, scale factor is K, and C is called the center of dilation, where you dilate from. Okay? All right. Get out your computers because we're all going to get into my Google Classroom. So we are 1B. So this is your Google Classroom, GIFOAXH. GIFOAXH. All right, so Jenny, make sure you have that written down somewhere. And then hopefully everybody's in. So then I'll go to Savas Realize. I'll make a new class now that I have all of you. Import a Google class. Hi, Mr. Hodgen.
Look at this crew.
Yeah.
Hey, that's my question too.
All right. So, we must be at the bottom.
Geometry.
Where am I? Fall 2022. Oh, my goodness. Really? Geometry 1B Spring. I think that's what I called it. Yep, that is. So we'll go with that one. Import class.
You do yours different than I do.
Okay.
I had a question though, but I'll let you screen. You're getting them signed up, I take it?
Yeah, they should be signed up now. So it should not be an issue now.
You don't import in from Google?
I did import in from Google. That's what I just did there.
So like right here, like how do I delete one of these if I want?
I don't know yet. I haven't gotten that far. So my library chapter. Boom.